Hello guys, welcome back to John's Workshop, and in this video we're going to be back onto the mill head refurbishment. So this is my Cormak ZX7045 Chinese import milling machine, and this is the third part in the series. So in part 1 you saw me reconditioning a ISO 30 spindle, and in part 2 you saw me make this stability ring to really firm up that. And in this video we're going to be machining, we'll just stand that back up, we're going to be machining the underside of my head for that stability ring to actually fix up to. And the way we're going to do that is by actually machining the underside of the head itself while it's still fitted to the machine. So there's two ways I could really do this, which is take the head off, give it to somebody else, get them to machine it on a much bigger machine, or try and machine it in situ on the head, on the machine even. And you may think, well, how are you going to do that? Well, that's the next bit. So I've had a very kind subscriber donation, and I'm going to call it out. So this is Dave Ticehurst in Australia. I've been talking about this for quite some time with Dave, and Dave very kindly earlier on this year made me in his own workshop a couple of spindles that will attach to each other with a belt drive, and one of them has got an ER16 collet on, so that allows me to fix both of those to my mill table, have a cutter in the collet pointing upwards, and hopefully machine the underside of the head. So that's all going to be very interesting, and as it says on the board behind me, there is no going back. And that's the polite version. So if I make a mess of this, and that was a polite version as well, I've made a mess of it. I do have a spare head here, and I've shown that in previous videos, so if everything goes absolutely catastrophically wrong, I've got a spare head that I could probably do something with. I'm not planning on things going too wrong, but you never know. So in this video we're going to be setting the mill up. We're going to be going through quite a lot of settings and checks and things like that. And the first thing I'm going to do before I remove the old spindle is tram my head with that spindle in it to make sure I've got my head trammed as best as I can possibly get it, because I'm going to be machining the underface. So obviously if my head's out of tram, I'm going to end up machining the underface in an unparalleled or unsquare condition to the spindle axis. So it's really important that I've got it trammed as good as I can, so I'll do that off camera, and then I'll join you on the milling machine just shortly when we're starting to get set up for actually machining the underside of the head and doing some strip down as well of the existing spindle. That all needs to come out before we start. So I'll bring you back shortly when we're doing that. I think I've covered everything on the board. Yes, other than the bottom point, which is exciting times. Okay, so we're at the mill. We've cleaned the table fully, we've stoned it gently to make sure there was no high spots, and we've got a DTI set up on the table with a very small amount of weight. I've just spent at least 20 minutes messing around with the head to get the best possible tram I can. So you can see we're on 0 on the clock there. If I spin round now gently around there, you can see we're 0. Can't really go any further because the clock disappears out of sight. And if I come back round this way, I need to move round. We're about 0. So that's the best I'm going to get. Probably, I don't know, yeah, it's 0 really. There's a tiny bit of movement here and there, but it's largely holding 0 all the way around. So happy with that. However, we are going to be doing a secondary check when we've taken the old quill out, and we've got our spindle set up on the table for milling the underside of the head. We're going to put the clock in the spindle, and we're going to run some checks up the spindle bore in the head, because of the quill bore, sorry, because obviously at the moment any error that I've got in this quill through slop or anything will be showing itself in this reading. So I'm going to do a secondary check by running a clock up and down in the spindle bore itself, in the quill bore. So I'll bring you back in a short while when we're starting to strip down our head and remove the Morse taper 4 quill that's in there at the moment. Okay, so 10 minutes later, and it literally is 10 minutes, these things are so quick to strip down. Both gear selector levers removed, 6 screws removed to take the front plate off. We've taken our depth stop, which is on the big bracket that clamps around the spindle here. We've just taken that off. We've taken our coil spring, return spring, off this side very carefully, wearing a glove because these things can spin if you're not careful. So I'd always advise you wear a glove because there's a little bit of spring sticking out, and if that spins in your hand it will just slice your hand to bits. So if you ever taking one of those off, always get a good thick leather glove on while you're doing it. And we've taken our hand wheel and our quill slow fine feed casting off. It's just 2 bolts, dead simple. And we've taken the pinion shaft, slid that all the way out this way, out this side. So, and we've also taken our key grub screw, or we've backed our key grub screw off that sits into the keyway in the side of the quill. So the only thing holding that quill in place at the minute is the quill lock. And we've jacked our head down onto a block of wood, so it's resting on the wood. So I'm going to unlock my quill now. It's not going to go anywhere because it's well supported, and all I'm going to do is wind my head up and hopefully jack the head off the quill. So we'll see how that goes. Okay, so we've got our setup almost complete. So we've got our 2 spindles, one for my input, which will be from a cordless drill, positioned on the table, clamped in position. We've got our belt, we've got our machine spindle. I think I incorrectly quoted ER16, it's not, it's an ER20 collet system on this machine spindle at this end. We've got all of that clamped down in position. We've got a spare studding in the middle here, which is going to be for our dabby dozy guarding system, which you can't all wait to see. And we've got our DTI in the dovetail clock holder, just because that's easy for now. And what I'm doing is, so I've done 2 things. I've checked the bore at this end, and we are 1/10 of a millimetre bigger on diameter than the bore that I've put through my stiffening ring. So yeah, there's a lot of slop in this front end of the spindle. So what I'm doing now is checking, so I've trammed my head as you saw. I'm now checking the tram a second way by putting this clock on in line with the x-axis in the bore of the spindle and dropping the head down, and I'm watching the clock to see how much movement there is on both sides. So obviously if the head was tipped one way, I would see the clock as I drop the head going plus, and on the opposite side I'd see it going minus. So I've done the checks and pretty good. I'm struggling to see much difference, but what I am seeing is a taper in this bore. So as I go further and further up the spindle, the bore is getting smaller and smaller, so it's bell-mouthed at the front end, which is what I suspected. But I've got an equal amount of movement on both sides of the spindle, so confident my head's trammed correctly. So I don't need to show you that. You wouldn't see it anyway because the clock disappears up inside the spindle, so it's difficult to try and film that. Okay, so I've repositioned the camera, and what you can see here is a element of the casting that there's a big radius here around there, which is basically Bondo or plastic padding. This will be a parallel cast diameter below this. The drop from this bottom face to roughly the underside of the head, bearing in mind I'm measuring onto a Bondo surface that's painted and it's all so uneven, is about 16 or 17 millimeters. So I've currently got 16 or 17 millimeters of spindle or quill bore that is 1/10 of a millimeter bigger than it needs to be. So the whole idea of this is to remove that 16 or 17 millimeters of material and to create a flat face on the underside of the head that is absolutely perpendicular, or as good as I can get it, to the bore, which is why I've spent all the time doing the tramming and double checking the tram. So what we're going to do is put a cutter in the spindle and drop the head down, and we're going to try and machine away this step, and then we're going to extend it outwards to get a diameter big enough that's past the PCD of the bolt holes that I've got in the stiffening ring, so that when I clamp the stiffening ring up it's got a nice flat surface to make to. That's the plan. So I'm going to do a bit more setup. I'm going to get my super duper guarding set up onto here, and I will bring you back when we are clenching our backside together and pressing go and see what happens. So we've got our cordless drill set up on spindle number 1. We've got our wonderful guarding in place. Thank you to the ambassador, whose receptions are noted in society for their host's exquisite taste in machine guarding. So this was an old Ferrero Rocher box, and that will only mean something to people of a certain age who used to watch adverts back in the 1980s. And we've got a 12mm solid carbide M mill, quite a sharp one, in the spindle. Got my DRO switched on. I've not yet clocked the centre of the bore. I'm going to wait until I've removed all of this material, because this is going to be probably quite aggressive, I think, when we get going. So I'm going to wait until I've done all the machining, the milling, and then we'll clock the spindle up finally before we put our pattern of holes in. So then I know it's good at that point. But I'm going to use my DRO to try and control my depth when I'm winding my head down to advance the cut that we're going to do to try this out. Exciting times. Let's see what happens. So I've touched on, and just to start with I've put 1/2 mil depth of cut on to try and get some sort of idea what this is going to be like. So here we go. Well, it cuts. Let's try a slightly bigger cut then. Go for 1 millimeter. Okay, I'm going to pick away at this and I'll bring you back when I've made some progress. Okay, I think I've gone as far as I'm going with this. So that's got 15mm material removed off that face, and I've had to nibble into this casting, this straight line bit of casting here, which is a bit that sticks down below kind of the bottom, the main bottom face. And I've got my stability ring here and just offering that up, lining up just roughly by eye with the bore that I can see through the middle. That's what we're looking like. So pretty good around the top here, no real big gaps to the rest of the casting. So I think I'm going to call that a day. Worst case scenario, I put the tapped holes in deep enough. If I ever need to take a bit more material off this bottom face, all I've got to do is drop the ring, take a bit more material off, and it'll bolt straight back up again. Not that I really want to do all of that, but yeah, so happy with that. That's a good flat bearing surface. That's going to be a nice fit up onto there. What I will say is my poor old DeWalt drill and the pair of batteries that come with it, don't know whether they're coming or going. It's had a proper workout removing 15mm of cast iron, 10, 12, 15mm thick in places with a DeWalt is quite a challenge, but all done. So next job is to get clocked up on the central bore, get zeroed on my DRO, and get set up for spotting the holes for attaching the stability ring. So just before we commit to cutting anything, I've done my usual idiot guide, got my Sharpie pen in the collet. I've been round, checked my DRO is giving me the right results, and in this case it's so important because everything is a mirror image of what you would expect, and every time you wind one of the axes thinking you're going to go to your next hole position, you wind the handles the wrong way because everything's, obviously the spindle's not, the spindle's opposite, the spindle's now on the table, so everything's back to front. So with all of that complication, I just want to make sure that this is all still working out, and it does look to be good. I just think everything's flipped through 180 degrees, so start position is 180 degrees out, and you go round in, yeah, it depends which way you go around, which way you follow the numbers, but yeah, it goes in the same direction but 180 degree flipped. So all my dots look to be in the right position, so we're going to get a spot drill set up now and go for it. Okay, it's the big fit up. So I've got my holes tapped in the bottom, didn't film that. I just used the DeWalt, eye-sighted square, in and out. Not ideal, but perfectly good enough for what we're doing. More than happy with it. So we've got our quill. I've taken my poly bag off the back end of it that's been protecting that bearing from any muck getting in for the last couple of weeks. We've got our ring. I've fitted the zerk fit into it, so I'm just going to put a bit of oil in there, and we've fitted our rubber seal. I've greased up all the spline, so that's all ready to go in, and we're just going to drop this ring onto the quill. Lovely. And then the next job is I've taken my paper bung out of the very top of the spindle, so I bunged that up just to stop any muck going down the spline at the top of the spindle while I had it all in bits. So the next job is we're going to line this up in the right place. I've cleaned all the quill bore with a rag and put that roughly centre, and I'll reposition the camera, and then we're going to drop the head down onto the spindle, and we're going to hope everything fits. So just before we do that, we're just going to put some lubrication all the way around the quill. Plenty of oil will not do it any harm at all. It's going to make a mess of my machine, but that's fine. Okay, I'll reposition the camera and bring you back. Okay, we've just had to do a little bit of jiggery pokery, but we've got there now. Just lining the spline shaft up with the collar in the top of the spindle. So I'm just going to wipe the excess oil off this face. When everything was clean, I'm leaving a tiny smear of oil on there, but I don't want loads of it running around. An even amount like that will be fine. And now we should be able to continue. This is where we find out if it fits. I'll lock our spindle lock at that position, and then take the head up. Okay, we're going to put our pinion shaft back in. Well, a dismal end to an exciting episode. So, unfortunately, either the rack on this International 30 taper spindle is obviously different to the rack on my Morse Taper 4 spindle. The pitch is correct, but the depth of the teeth is obviously wrong, because the pinion will not go in, it will not engage all the way through. As soon as I get into these bearing diameters, I can see it pushing off at the back side. I've even taken the bearing out the other side to see if that helps, and the pinion would then go through the rack. Even without this bearing in place, it still won't go through. So what I did do was went and looked out the other rack that I got with the spare head, which strangely enough seems to be a better quality one, because it looks like it's been heat treated, whereas the one on my mill doesn't. And that one's exactly the same. That one won't fit either. So got the same problem. So that is the end of this episode, unfortunately. I'm going to go to the board, we'll close this out, and I will have a think about what we do next. Well, there we go guys, still smiling despite the challenge. So as I said, disappointing end to a very exciting episode. I've really enjoyed doing the milling on the underside of the spindle. I think the fit of the stability ring is really good, so that is going to be beneficial. I've got to sort this rack and pinion problem out, so really the next job now, I need to get both spindles out on the surface plate, get some measurement gear out and start to try and detect what the difference between the two racks are, to see whether I can do anything with that. And the challenge is, do I machine the rack or do I machine the pinion? Again, once I've got this fixed in place, I've no intention of swapping back to the Morse Taper 4, so I could machine the pinion, but the proper job would be to machine the rack. I've got no gear cutters at all, so we would need to be making a single point fly cutter, gear, ground up, something like that, to do anything with either the rack or the pinion. So yeah, a bit of head scratching to do here. Not all lost. What I can do is, and what I will have to do, is put my Morse Taper 4 spindle back in, set everything back up, but I can use the collaring with the Morse Taper 4 spindle, and I'm going to need to do that to do any machining of either rack or pinion anyway. So that's the next job really, get the machine built back up with the Morse Taper 4 spindle once I've done some measurement. So I hope you've all found that very interesting. It's been quite something different, never done anything like that before, and I'd like to put a thank you out again to Dave for his very kind donation of the two spindles. Generosity knows no bounds. Not only did he take all the time to manufacture those and make them for me, knowing I was doing this project, but also post them halfway around the world. So thank you, Dave. And not all is lost yet, so I've still got the benefit of the collaring with the Morse Taper 4 spindle, and I am going to persevere with this until we get the International 30 spindle to fit, and hopefully that will make some interesting videos for all of you guys to watch. So thank you all very much for watching. Thank you to the subscribers and new subscribers, and we'll catch you all very soon on another video when we'll be fixing this.